Welcome to Contemporary Math. This is our first lesson. We're doing about sets and subsets today. So a real short first chapter too, guys. There's only 3 lessons. Remember, there are no tests unless you are concurrent credit. We'll do that for a final exam, but there's still no tests, only quizzes. I do that about every 3 lessons. So we'll do these 3 lessons, and we'll have a quiz for it. Yes, we will study before the quiz kind of stuff also. So here's what we'll get started with. A set is a collection of distinct objects called elements. We're going to talk a lot about sets today. So what's a set? It's a collection of distinct objects called elements. And what they do is they use these fancy schmancy brackets. When we start using our online homework program, which will take a little getting used to of how to type stuff in, but you'll figure it out by next week. Sometimes you got to type the little curly brackets. Sometimes you don't have to type the little curly brackets. We'll figure that all out. But what's cool about sets is here's some examples. Like if I made the set of all even numbers, cool, that's a set of something. It's like here's all the evens, 2, 4, 6, 8, 10, 12, and it goes on forever. The set of all books written to travel to Chile. What a weird set of things, but it's a set of books about how to travel to Chile. And then what they do is they kind of list them like this. The order doesn't matter either. Like if you want the set 1, 2, 3 to be there, it's cool to be set 3, 1, 2. Like whatever order they're in, it doesn't have to be numerical or anything like that. They just all got to be in the set, right? And they're only there once. We'll talk about that a little bit there also. But here's a couple examples, 1, 3, 9, 12. That's just some weird set of numbers right there. And here's a cool set, red, orange, yellow, green, blue, indigo, purple. Anybody know what that is? That's the rainbow right there. That's the set of colors in the rainbow, right? They just mathematically just listed it in a set. It's like, cool, these are all the sets of colors in the rainbow. So our homework today is almost the exact same questions that we're going to do right here on the practice. Remember, you get to use your notes on quizzes, so the better you take your notes, the better you'll do on quizzes and stuff like that. So list out the set of letters in the word banana. So they got this guy, and here's how we'll start. I'll put the fancy bracket. It's kind of hard to write. If you can't make it perfect, make it a squiggly parenthesis, but everything's on the computer, so you just literally type that bracket. You know, you'll find it on your keyboard. But I'm just going to go in order. The first letter I see is a B, so I'm going to put it. It is a capital letter, and I don't know the answer if a capital B versus a lowercase b matters when you type it on the homework. We'll find out, you know. It's like we'll kind of see. But B is in the set. Then I'll put a comma. Is an A in that set? N is in that set. And is there any other letters in the set that I haven't listed? Because there's more letters in the word banana, but aren't they A's and N's, right? Have I taken care of them all, right? So that's it. And then we close that dog up. So the set of letters in the word banana is B, A, and N. And I'm not sure if the capital letter matters or doesn't matter, right? Cool. So we'll find that out when we do homework. What would this be? A verbal description of this set, the letters A, E, I, O, and U. What are those? Those are the set of vowels, right? You know, so the set of vowels. It's a weird word to spell, but that's why they had them as a set right there. It's a set of vowels. A set of vowels. The set of numbers greater than 3 but less than 11. So they kind of mean the integers, like no decimals or anything like that. So should 3 be in there or 3 not be in there? Yeah, they say greater than it. So how about we start with 4, right? And then 5, 6, 7, 8, 9, and 10. And they say less than 11. Do you want 11 or do you not want 11? Not 11. Again, not trying to insult you guys' intelligence, just kind of learning a little bit about your math ability at this point. It's like we kind of get it, right? It's okay if you struggle. We're cool with the set of those guys right there. Nice. So let's see what we got here. Here's some fancy notation. That kind of gets weird. This is why I want you to have notes to look stuff up, because you're going to see some things like, I don't know what this says. So this fancy schmancy symbol right here. First question, do you see it kind of looks like the letter E, you know, but it's not quite an E. It's like a curly guy. It stands for an element of. It's an element of the set. For example, here's set A, 1, 2, 3, 4. Is 2 an element of that set? Meaning, like, is 2 in that set? Yes or no? Yeah. Is 7 an element of that set right there? It is not. Are you with me on that? That weird symbol means you're an element of the set. So they changed the set on us. They now have this one set M. It's got 1, 4, 9, 16, and 25. True or false? Again, knowing how to read it is the hard part. That says 2 is an element of set M. Here's set M. True or false? 2's in that set. False. Right? So just put that. Is that okay with you? Like 2 is not in there. And then, of course, here's a brand new symbol. We just learned element, but you see how they crossed it out? You know, they put that little strike through in it. That means it's not an element of. So it's kind of weird. They say 4 is not an element of M. Well, my question is, I'm going to do it like this. Is 4 an element of M? 4 is. They're saying it's not. It's like true or false. 4 is not an element of M. 50-50 shot, guys. True or false? Is 4 not an element of M? That's false, right? It's false. And then what do you think? 11 is not an element of M. That's true. 11 is not in this set, right? But that can be tricky. It's like the not thing is such a backwards way of thinking, you know? So the good thing is on our homework, it'll tell you if you did it right, it'll tell you if you did it wrong, but you might have to do another problem just like it, you know, kind of stuff. But it's like, okay, if you mess up, it'll show you kind of stuff. So, but that's kind of weird. And then what we get is, besides sets, there's also some things called subsets. So my example here is there's some student named Chris. He's got a few Slipknot albums, right? He actually owns 3 of them. So like his cool collection, he's got a set of Slipknot albums. But that's not all of them. Like he doesn't own them all, right? He's just got what's called a subset. Isn't there more Slipknot albums than 3 of them, right? So he has a set, but it's not a complete set, right? So that's called a subset, which has a very, very fancy symbol, right? It's kind of like a less than symbol, but it's not. The subset symbol looks like this. You know, it's almost like a C. And you also see one where there's like a little bar underneath it. You can totally treat that bar like the less than or equal to or the greater than, like the bar means is equal to, right? So let's just kind of dive into some problems, and we'll see if we can understand the symbols after that. So here's 3 sets. Set A, all the even numbers in the world. Set B, 2, 4, 6. And set C, 2, 3, 4, 6. Got 3 different sets down there. Here is B, this says a subset of A. Is 2, 4, and 6 a smaller set of even numbers? Yes or no? You with me on like a subset? Because 2, 4, and 6 are totally even numbers, but it's not all of them. Are you with me on it? It's called a subset. And because they didn't put an equal to bar, that means it's just like totally less than it. It's smaller than that. That's a proper subset. This is smaller than this, right? It is a subset. It's proper. So let's try this. Is C, I'm totally cool if you say less than or equal to also, is C as a set less than or equal to A? Is this guy smaller than or equal to even numbers? 2, 3, 4, and 6. Like, what do you think? Is 3 an even number? Nope. You know, so that is false, baby. That's weird. And this is my job to do a couple examples with you, and then when we do homework, I'll walk around and help you with them, right? But this doesn't work because 3 isn't an even number. Like, you got to be what they're asking you below that in that case. So, cool with that? How about this? Is B less than or equal to C? Let's go through it like this. B has 2 in it. Does C have 2 in it? Yep. B has 4 in it. Does C have 4 in it? Yep. B has 6 in it. Does C have 6 in it? Is B less than or equal to C? It's less than, right? And so that's a yes. Are we okay with that? So that works. You know, that's true in that case. And then here, all this is saying it's the same dang thing, right? It's the same dang thing, but is it truly less than? The things in B, weren't there 3 of them? Is that properly smaller than this, which has 4 things in it? Is 3 smaller than 4 in that case? So that's a yes as well. But man, that is weird, right? That's a true. This guy is so let me ask you this. I'm going to make up a new set. D, 2, 3, 4, and 6. There's a new set, D. Is D less than or equal to C? Are D and C exactly the same? That's exactly the same. So that's a yes, right? Because they're the same freaking thing, right? They are less than it or equal to it in that case. Is D a subset of C? No, it's not, because they are not exactly the same. And if you need help with that later, I will help you. Oh, one more. What do you think this means? That means it's not a subset of A. Like they crossed it out. So is C not a subset of A? Is this guy not a set of the even numbers? That's true, because he's got an odd in him. But man, that's not easy for a lot of people. It's not, you know. So let me help you if you need a couple bit of questions on that. And then last couple right here, let's do this. Let's just select on homework. This is literally a homework question that I snipped out and I just put on paper. If there's a box there, that means you just check all that apply, right? So it says select all of the following sets. That could be this. If A is less than or equal to this guy, right? So let me just roll with this. Let me erase that. 1 is 1 in this set, yes or no? Yep. 7 is 7 in this set. Yes. 12 is 12 in this set. This guy, sorry, I hit the wrong button. I apologize. This guy, we checked the box. That guy is smaller than that other dude, and everybody was in there, right? Cool. How about this? Less than or equal to is our symbol. 1, 3, 4, 7, 9, 10, 12. Is that smaller than or equal to this guy? He's bigger. Doesn't it have extra guys in there? Like 9 is in this guy, but he's not in this guy, right? And 12, oh, sorry, it was 10, you know. So this, we don't check the box, right? Because he's not less than or equal to it. He's bigger than it. It's got extra crap in there. And then this dude, 1, 3, 4, 7, 12. Is it less than or equal to this guy? He is the exact same thing, so we check the box. That's only because this little line was underneath there. If that line wasn't underneath there, you couldn't check that box, right? Because that's the equal to bar. 3, is 3 less than or equal to this guy? Totally, right? 3 is in there, so we check it. And then, sorry, you may have seen this symbol before. I skipped over it on that. That's the empty set. You realize it's a set and there's nothing inside of there. That was like back in some Algebra 1 days when like you'd solve something and there was no real answers to it or anything. You know, it's like the empty set. There's nothing that satisfies this. And here's a weird fact. The empty set is a subset of everything. Because isn't this totally smaller than that, right? It's empty in that case. So we do check the box on that. The empty set is a subset of any set in the world, right? And then this guy, what do you think? Yes or no? Is this less than or equal to that guy right there? Nope. Nope. 2 is not in there. This guy's too big, right? This guy is too big. I know. It's already a long day. This is our last one. Oh, we got the rectangle stuff down at the bottom. That's kind of weird. If you need help with that, I will help you. And now they reversed it. This, they're asking you if this is the small boy. Can this guy be the small boy? What could X be? So here's my question. Like 6, 8, and 10, since he's on the left side of this guy, have to be inside of these brackets for it to work. Is 6, 8, and 10 inside of our first option, right? So this pink dude is smaller than this guy. He works. Is this guy work? Is 6, 8, and 10 in there? I know 8's in there, right? But you got to have all of them. Is 6, 8, and 10 in there? So we don't check that guy. Is the set of all even numbers going to work? Well, I guess I got to ask you this. Is 6, 8, and 10 in the set of even numbers? Yep. So that guy works. And the empty set doesn't work because the empty set has to be on the left and the other guy is on the right. This guy is backwards, right? So the empty set is not in that one. That's really, really, really weird. And I would stop here if the next question wasn't homework questions, right? I try to get you prepared for homework, but a little bit of geometry review about rhombuses, rectangles, and squares. I got the definitions typed out for you. It's not much geometry review in this class anyway. It will be okay, right? But a rhombus is a quadrilateral with 4 equal sides. A rectangle has 4 right angles. And a square is, in all honesty, the child of those two. If those were the parents and they had a baby, you get a square. It's got 4 equal sides and 4 right angles. So what do you think about this? They say let R be this set. They say let H be that set. And they say let S be this set. Is H a proper subset of S, or is H a subset of S? Is the rhombus smaller than squares? Rhombus has just got 4 equal sides, right? You know, what do you think? I would say yes, it is. If you are above this guy in the hierarchy, you're smaller than it, right? And again, some people get that and some people have that completely backwards. That's normal, right? It's like, yeah, a rhombus, there's less rhombuses in the world than there are squares in that case. What about, is a rhombus a proper subset of, rectangles. Is a rectangle a proper subset of squares? That is also true. Rhombuses are less than squares. But hopefully the last one kind of makes sense. Is a square smaller than the set of all rhombuses in that case? That's a false one. That's a false one. And one more time, if you have any questions, we got over an hour to work on 10 questions of homework, dude. You know, it's like we should get them done in under probably 25 minutes. So